Hello everyone, welcome back to my channel. In this video, I will talk about data modeling. It is one of the most important topic if you are working on creating the data visualizations that is on Power BI or any other BI tool. It is very important to know the data modeling concepts, right? It is used in SQL as well. So if you have those kind of concepts, those are similar. Right. So first of all, we have to understand what is data modeling, and then there are various other things like primary key, then foreign key, what are the fact tables, dimension tables, which are the types of schemas. So I would be talking about all these things in this particular video. Right. So it is very important for you to stay till the end if you want to understand end to end what is data modeling. And I assure you, if you watch this video till the end, you would understand the things that are required for data model. Right. So first of all, let me just start with what are the things that are covered in this video. First section will include what is data modeling, right? What is data modeling? Then it will include why do we want data modeling, what is data model, and what are the attributes of a good data model. So I will be covering these four things in section number 1. All right. Then if I go ahead in section number 2, I will talk about primary key, foreign key, then what are the fact tables, what are the dimension tables. These are very important concepts. So if you want to understand data model, please study this. This is very important. Then what are the types of facts, then what are the relationships, types of relationships. These are really important concepts. So I would really request you to watch section number 2 and you will understand the concepts in data model. All right. And finally, I will talk about section number 3. This is what is data warehouse schema and what are the types of schema and what are the difference between these schemas. So basically the most famous, you can say, schema is star schema. Then we will talk about snowflake, then finally galaxy schema. Right. So you need to understand which schema you have to apply for which particular data set. So it is very important to work on these particular concepts. And finally, in section number 4, I will talk about data modeling workshop that I will do practical end-to-end analysis and working on data modeling. So where we will do importing of the data from various different data sources. Then we will understand which are my primary key, which are my foreign key, how we are connecting by one to many or many to one relationship. And then we will work on the formulation. So it is very important to watch this video till the end if you are looking for data modeling concepts. All right, so let's get started with section number 1. What is data modeling? All right, so what is data modeling? So as you can see, this is my table structure that is created on Microsoft Power BI. You can see there are various tables, right? So you can see table 1 is account table, then there is resource table, booking table, incident type table, product table, work order product, work order, customer asset. So there are multiple tables, right? So these are the real case studies where you have to understand how to create data models, because you would be having multiple tables, right? So which table to connect with which table, that is really tricky, right? So you have to understand which primary key will become my foreign key for other table and which are my unique keys. So I will talk about all those keys later on, but you have to understand, right, these concepts. So first of all, here you can see this work order looks like this is my fact table, and these are my dimension tables. So I'll just talk about fact table and dimension table as well in my upcoming slides. But right now, just understand these are my tables and these tables are connected through some columns, right? So if you say work order is connected to work order type, right? So I don't know which column it is using to connect, but it is one to many relationship. One means from here it is unique from one particular column, and this asterisk sign means many. All right, this itself says that this should be my dimension table and work order should be my fact table. All right, so in a nutshell, if I have to tell what is data modeling by definition, data modeling in Power BI refers to the process of structuring and organizing data to create a meaningful and understandable representation of data for analysis and visualization purposes. This involves creating relationships between different tables, defining measures, calculating columns, and creating hierarchies and other data structures. Right? It is similar to you organizing your room. For example, you have books, you have clothes, so you organize books in a particular bookshelf, you organize clothes in your chester or cupboard. So you are organizing things, right? So that I can understand, I can analyze and visualize properly, I can see that my room is looking better, right? This is the purpose of data modeling. It is the process of structuring and organizing your data efficiently.
Right, so why do we want data modeling? There are various reasons of it. First is to create meaningful relationships between the tables. So if you say there are various tables which are coming from different data sources, so how will you connect them so that you can make the sense out of the data source, right? So defining the relationships between these tables is very important. Second is combining the data from different data sources into single view and create more complex and powerful reports. So in order to create powerful reports that you can share across with the management, you need to work with different data sources. And if you have to work with different data sources, that means there are multiple tables that you're getting, and it is very important for you to connect the dots, right? So you have to connect these tables so that you can get the data from all the tables required. Now the second reason is to optimize the data for analysis, right? So you have the data that is coming from SQL, let's say from Dynamics or SAP or even Excels, right? So you have the data, but how to work on that so that you can optimize, and whenever the user is watching or refreshing the report, he is viewing that in seconds or maybe milliseconds. So this is transforming and shaping the data that makes sense for your specific needs, right? So this is optimizing the data, creating the calculated columns and measures, applying filters and defining hierarchies to help organize and analyze your data effectively. So this will also come under data modeling. Third is to create efficient and accurate reports. So ultimately the objective is to provide the accurate reports, right? So you don't need to just create beautiful reports but the values are not matching. You need accuracy, right? So for that, data modeling ensures that your reports are efficient as well as accurate by eliminating redundancy and inconsistencies in your data, right? This makes it easier to create and maintain reports that accurately reflect your business data. So it is very important for you to create the accurate reports, and for that you need to eliminate the redundancies and inconsistencies in your data. If you want to eliminate your redundancies and inconsistencies, you have to create the data model which is efficient and useful in your particular problem statement. Finally, to improve the data quality. So data modeling can help improve the quality of your data by identifying and resolving any particular issue such as missing data or inconsistent data, duplicate records or incorrect data types. So what data modeling will do is it will identify and resolve all these kind of issues so that the quality of the data that you're getting is exponentially improved. So overall we have four main reasons why we want data modeling, right? So to create the meaningful relationship between the tables, to optimize the data, to create efficient and accurate reports, and finally to improve the data quality. All right, now let's move to the next topic. What is the data model? So I already explained this particular part. So these are the tables that we are having. We are having the relationships between the tables, and overall this is called a data model, right? So in Power BI, a data model is a collection of the tables. So it is the collection of tables. So you can have 2 tables, 3, 5, 10, 100, and their relationships that are used to analyze and report on data, right? The data model defines how the data is structured, organized and related to each other, and it serves as the foundation for creating reports and visualization, right? So you are getting the data, you have to structure them, you have to organize them and make the relationships between these tables so that when you are working on the visualization, you are able to fetch the data and get the analysis done. The data model in Power BI is created using Power Query Editor. So this is one of the way. So for example, you have one particular table, you open that table in Power Query Editor, and from that particular table you can extract the dimension tables, or you can say masters, and then work on the masters and fact table. So that is dimension table and fact table, and you can work on star schema. So that I'll explain in the later slides. Now, so you can create using Power Query Editor, where you can connect to different data sources and transform the data into the desired format. You can create relationships between these tables, define calculated columns and measures, and create hierarchies and other data structures to organize and analyze your data. So if you thought the data modeling is just about the relationships between the tables, right, then you're wrong, because in data modeling, everything comes in. When you are importing the data from different data sources, you are creating columns or measures, or you're creating the hierarchies, or you're manipulating the data in Power Query Editor. You are working on data modeling. All right. Now, what are the key attributes of a good data model? So now we have understood the purpose of data model. What is data model? Now, what are the key features through which I can identify, yes, this is my good data model, right? So these are, first is scalability. A good data model in Power BI should be scalable, which means it should be able to handle large volumes of data without affecting performance. So if I have 10 records and if I work on that report, it will be very easy. It will run like a charm. But if I have the report with 10 crore records instead of 10 records, then the speed might be slow, right? Now, it is very important for you to work with large data sets. And if you can work with large data set without affecting the performance, then you are preparing the good data model, right? So how this can be achieved? This can be achieved by optimizing the data model for efficient data retrieval and minimizing the redundant data. I will work on this in the project. Second point is simple and easy to understand. So your data model should be simple as well as easy to understand, right? So the relationships that you are building between the table should be clear and easy to follow. And the data model should be organized in a way that makes sense to the end users. So it's not the job of the Power BI developer just to create and share with the business users. For Power BI developer, he has to create the good data model who can be understood by business users. For example, you create one data model and you publish and share across the report with the business users. But if business user wants to understand the backend, he is easily understanding the nomenclature, right? So you have to prepare it very clearly. Third is consistent and accuracy. So it is obviously very important. This means that data should be normalized. So it should be normalized to reduce redundancies and inconsistencies. So in short, if you understand, if you're reducing the redundancies, if you're not having the duplicates, you're already improving the performance of the dashboard. Fourth is flexibility, right? So it should be designed in a way that makes it easy to add new tables or fields. So if you want to add new tables in the later stages, or if you want to add columns, it is very flexible and you can make the changes. Fifth is optimized for analysis and reporting. What is the purpose of Power BI? It is about analysis and reporting, right? So if we are optimizing it, then we are saying the data model is good. It should include calculated columns, measures, hierarchies, and analyzing the data for creating the meaningful reports as well as visualization. Finally, the document should be well documented. The report that you're creating, right? It should be well documented so that you can understand step by step what is happening. A good data model should be well documented to help ensure that others can understand the data model that you have created. This can include the documentation of the data sources, the data model design, and the relationships that you have built between the columns, right? So whatever the schema you have applied, star schema or galaxy schema, then what kind of calculated columns you have applied, whatever is done, so it should be well documented, right? For example, you're importing data from, let's say, SAP database, right? So it should be documented. What is my user ID? What is my password? If you have connected through APIs, then you should have the details of API connection and what are the things that you need to make sure. For example, you're connecting via VPN, then you need to have the details of VPN as well, right? So you should create a document so that everything is there. All right. So in short, these are the 6 major attributes of a good data model. Alright, so now coming to the section number 2, right? So this is something which I feel is one of the most important topic if you are talking about data modeling. So this is primary key versus foreign key. Alright. So first of all, I want to tell you the definition of primary key. Then I will tell you the definition of foreign key. Then I will show you on Power BI what is primary key and what is foreign key on the table. So primary key in Power BI is a column or a combination of columns that uniquely identifies each row in a table. The primary key is used to ensure the data integrity and it is essential for creating the relationships between the tables. So when you're creating the data model in Power BI, it is important to identify the primary key. Alright, so what primary key is? It uniquely identifies each row in a table. So if you have 5 records in a table, there must be one column that will identify that particular row, right? So let me just tell you what is foreign key as well, then I will show you in the table. What is my foreign key in Power BI? It is a column in one table that refers to the primary key in another column in another table. The foreign key is used to create the relationships between the tables in the data model. For example, if you have a customer table and order table, the orders table may have a foreign key column that refers to the primary key column in the customers table. This allows you to create a relationship between these two tables and analyze the data across the tables. Now, if you see, this is my order table. I have order ID, I have item name, customer ID, location and sales. Here, if you see, order ID is my primary key, right? I can see these are distinct. Now, if I see the customer table, here my customer IDs are C100 to C104. You can see or you can sense that customer ID should be your primary key if I have to see my customer table, right? I have customer ID, customer name, location, priority pass. So you can see name can be different, name can be same. For example, there are 2 Rahuls, right? But customer ID should be different for each Rahul as well. Location can be same. You can see here I have 2 Mumbais, right? So this can never be your primary key. Priority pass can never be your primary key, right? So we should not create these as my primary key. Primary key will define each row uniquely. So C100 as customer ID will identify Rahul Subramaniam, location Delhi, and priority pass yes, right? C102 will tell me Kenny Sebastian, it is in Mumbai, and priority pass no. So it is identifying uniquely the complete record, right? So that's why I can say this is my primary key. All right, so here this is my primary key. For this is my customer ID. In order table I am getting the customer ID, so I can connect customer ID and customer ID. So in the table order I can say that customer ID is my foreign key for the primary key customer ID in the customer table, right? But in order table I can say order ID is my primary key. So you can have multiple keys in one table. So you can have primary key as well as foreign key in one table itself. Alright, I hope primary key and foreign key concept is clear, because this is very important. If you are going ahead with data modeling, you need to understand what is primary key, what is foreign key. Alright. So now if I have to talk about the fact tables and dimension tables, right? So what is the difference between these two tables? What are these concepts? I will tell you in this particular slide. Now, so if I have to tell you about the fact tables, so there are many different types of fact tables, but most people could instantly recognize one when they see one. A quick example of the fact table would be a sales table that contains column like sales ID, date, store ID, product ID, unit sales. So in short, fact table is a table which is continuously changing. So for example, today I am getting sales, so it will be updated in the fact table. Tomorrow again, if I punch in, I get the sales, it will reflect in the fact table, right? So fact tables are the tables, you can say transaction table, where I'm getting all the table data every day, right? Whereas the dimension table is different, but in fact table, it will include two types of fields, right? Either the column is the key column to the dimension table, or it's a fact. Those fact columns must be either numeric or aggregated field. For example, in these 5 columns, sale underscore ID, it is my key. Date is also my key. Store ID is also my key. Product ID is also my key. Unit sale is my fact. So what I'm saying is there are 5 columns in this table. Sales underscore ID, it is my key. That means I must have another table where I'm having sales ID, then all other details. This will be my dimension table, dim table, right? This is my dim table, right? And from here, I will create a relationship with sales ID, one to many, right? Similarly, I will have another date table, right? And date table will be mapped to this particular column. Again, I will have store details, store master, that will include store ID, store name, store location and everything, and it will map to store ID. Similarly, with product ID, I will have my product master, that is another table. So all these tables, store master, product master, sale master, then date master, all these tables are my dimension tables. You can say these are my masters, right? And finally, this unit sales, this is keeping on like changing. It is changing every day, right? So this is my fact. Now if I have to tell you the definition of dimension table, it contains metadata that describes the fact table. Continuing the sales example from above, what we discussed, right? Example of dimension table might be store table that includes store ID, store name, store city, store location, right? So we created one table, right, for store underscore ID. So that will be master, which will include all these kind of columns. Finally, you can see the store underscore ID is the primary key for the table that relates back to the sales fact table above. The other fields would be dimensions that describe the fact table, right? So there are two types of table, fact table and dimension tables. Dimension tables can be said to be like masters, and these are not changing all the time. Fact tables are on contrary changing every day. These are my transaction tables. Alright, so now coming to the types of fact tables and types of dimension tables. So if I have to talk about the fact table, there are 3 types of facts. First is additive, right? So first is additive, second is semi-additive, third is non-additive. So what is additive fact? These are the facts that can be aggregated across all dimensions in the fact table, right? So that means all the columns are aggregated. Examples of additive facts include sales revenue, profit, and quantity sold. These facts can be summed up to higher level of aggregation, such as by month or by year. What is semi-additive? These are the facts that can be aggregated across some dimensions, but not all. For example, you can include bank balance, inventory levels, right? So for example, in inventory, you can sum up, but it will be cumulative, right? You can't say from day 1 till day 10th, whatever is the inventory on that particular day, if you sum, you will get the total. No, because each and every day you are selling also, right? So inventory minus sales will be your net inventory. So in this case, this will be semi-additive. Finally, third one is non-additive. This is the fact that cannot be aggregated at all, right? Examples of non-additive facts includes averages, ratios, percentages. So if I have a column with percentages, you can't aggregate them, right? So if I have 5 records, each record is telling me 10%, 5%, 15%, 20%, 25%. So you can't aggregate that. These facts require special calculations to be used in aggregate functions and cannot be summed up like additive or semi-additive facts. So these are the 3 types of facts: additive, semi-additive, and non-additive. In semi-additive, one of the most important concept is inventory and bank balance, right? So if you want to work on inventory dashboards or finance dashboards, so you will work on this concept. In additive, you will have simple sales, revenue, or profit, or you can say quantities, whatever. So all the measures which can be calculated are additive. In non-additive, you need to remember averages, ratios, and percentages. These are the kind of non-additive facts. Now if I move on to the type of dimensions, there are 2 types predominantly. One is connected dimension and second is disconnected dimension. A connected dimension is a table that is directly related to a fact table through one-to-many or many-to-one relationship, right? So they can be either one-to-many relationship or many-to-one relationship between the fact table and the connected dimension, right? So in short, you have connected dimension where you're saying that it is connected with fact table. Second is disconnected dimension, which is not connected, which is not directly related to the fact table. It contains a list of unique values that can be used to filter the fact table. A typical example of disconnected dimension is the date table that contains a list of all possible dates. By linking the date table to the fact table through a calculated column, users can easily filter the fact table date by date. So if I connect a date table with fact table via one particular calculated column, then I would say this is a disconnected dimension. Otherwise, if I am connecting the date table directly with the fact table, then it is not disconnected dimension, it will be my connected dimension. All right, I hope this is clear. So now I have discussed about the facts and the dimensions and what are the types of fact table and dimension tables. Now let's understand what are relationships. So now we have understood, we have fact table, we have dimension table, so we have different types of tables, but you have to connect these tables, right? You have to build a relationship. That relationship can be one-to-many, many-to-one, or one-to-one. So I will explain you this. For example, first of all, what are relationships? If I have to tell you the definition, relationships in Power BI are connections between 2 or more tables based on common fields or columns. Relationships are created to enable the integration and analysis of data from different tables in Power BI reports or dashboard. So you have multiple tables, you have to connect them, right? That can be based on common fields or columns, and then you have built a relationship. So once relationship is built, if you filter from one particular table, you can get particular result from the second table as well, right? So you are connecting a relationship. For example, if you see here, there is my product master, I have store master, I have fact sales, so I have sales data as well. So you can see there is a one-to-many relationship between dim product and fact sales. So let's say it is connected on product underscore ID, right? So it is connected on product underscore ID, right? So whenever I filter from this particular table, if I filter out product category, so all the data from here also will change because I have already connected the product ID with my product ID here, right? So it's not necessary to get product category over here from this table and then only the fact sales table will filter out. No. So once we have created the relationship, whatever you use column from here as a filter, the data will change here as well, right? So this is very beautifully explained in Power BI as well, like why it is used, why there are dimensions, why there are facts, because you have to create separate masters and then you have to use them in the filter so that you can get the desired result, right? So as I was explaining, there are two main types of relationships. One is one to many, second is many to many, and then it can be one to one as well, right? One to many is the most common type of relationship. You can see here, this is one and this is asterisk sign, asterisk is many. So mostly from masters to fact or dimension to fact table, the relationship is one to many, right? So this is very important, and many to many is not recommended majorly. Like in this type of relationship, each record in one table can be associated with multiple records in another table and vice versa, right? For example, in a movie database, each actor can be associated with multiple movies. So Shah Rukh Khan can have multiple movies, right? And in each movie we can have multiple actors, right? To create a many to many relationship in Power BI, a bridge table or a junction table is required to connect the two tables. So I will show you this as well. So how to create the bridge table and how this can help you actually, right? And finally, this is one-to-one relationship, which is hardly used, but you should know what is one-to-one relationship. Each record in one table is related to only one record in another table and vice versa. So there is literally only one record which is matching in each table. This type of relationship is less common in data modeling, but it can be used when there is a unique relationship between the two tables. Alright, so this is about relationships. We have majorly two relationship types, one to many and many to many, and third one to one can be used sometimes. Alright guys, so now we are on Power BI desktop. As you must have seen my previous videos on Power BI, right? So we have three views. One is report view. Here you can see this is my report view. You can create the visuals or dashboard over here. Then I have the data view. I will have the data tables, right? So I can have dim date right now, then dim product, dim stores, and then fact sales. I have 4 tables right now. I'll explain you all the things. Then I have model view, right? So this is where you're working on modeling, right? So whatever the tables you're having, it will show over here, and then you have to create the relationships accordingly. One option is you go to file and select auto relationships. So whenever you import any particular table, then Power BI will automatically detect the relationships. But I would suggest you to unselect that particular option, because you yourself has to select and create the relationships. That is recommended. Right here, let me just delete the relationships as of now. Right, so now you can see this is my dim date, my dim products. Let me just explain you the data set. This is my dim date. I have created a DAX to have all these kind of columns: date, then year, start of year, end of year, month, start of month, end of month. Everything is here, right? So if you want this script, let me know in the comment below. I will add that, right? Then if I go to dim products, I have product ID, product name, product category, product cost, and product price. If I go to dim stores, then I have store underscore ID, ID versus store name, store city, store location, and what is the opening date of the store, right? And finally, I have fact sales. So this is my fact table. I have sales underscore ID, against each ID, against which date, and store ID and product ID, I have units, right? So from here I can get the sales. So now if I want to get what is my store wise sales, can you tell me? Store wise as in store ID? No. So in my opinion, store is store name. So if I let's say filter from dim stores my store name, right? So I have all the store names over here, correct? Now I'm saying from fact sales I want sales. So this is my units. So now if you see, for each store I'm getting the same number of units. So this is the total number of units that has been sold for this particular data set. This is 10,90,565, but it is not showing me for each and every store. Why is that? Because these two tables are not connected, right? So if I go here, you will see dim stores, this table, and fact sales, this is not connected. So if I connect this via store ID, because I can see store ID is here as well as here. So if I just select and drag to over the store ID, my relationship will build, right? So you can see this is one to many. Now let's see if the changes happened on the dashboard or not. See, so for each store you can see number of units, which is bifurcating beautifully. Now you can see total is 10,90,565, but individually also you can see now, right? Similarly, if I add another table for the product, let me just add product from here, product name and sales. So you can see again for each product I am getting the cumulative or total number of units sold, 10,90,565. But I want for each product how many units were sold. So I will go back to the model view. From here I will connect dim product with the fact sales. For this I can see product ID is my lowest level that can be said as the SKU. I will connect with the product ID. Right, so now it is connected. If you hover here, you will see which all columns have connected these two tables. Now if I go back to the table, you will see all the product wise sales I am getting, right? So this is amazing. Now with just one relationship you are getting the data. So this is the power of data modeling, right? If I just right click, if I go to property, you will see what is the understanding. So cardinality is many to one. So here you will see fact sales towards the product is many to one. So if I interchange, if I say this is my dim product and here I will add fact sales, then it will be one to many. So here in a nutshell, many to one or one to many is same. It's just that tables are irreplaceable, or you can say tables are replaceable. You can say fact sales is coming down and dim product is going up. So here you can see there is cross filter direction, so single or both. So by single you're saying fact sales and dim products, there is only one direction. You can see here my dim product will filter my fact sales, not vice versa, right? If you want fact sales to filter out dim product, then you have to change the cross filter, right? As soon as I click both and click OK, you will see the arrows changing over here. See over here you can see there are two arrows now. Initially it was only one arrow, now it is two arrows. But this is not suggested in general. Like if you need to do these kind of cross filter direction, you can do, but generally it is single, right? So I will change it back to single, right? Similarly you can map fact sales with dim date. So here this date should be mapped with the date of dim date, right? So this is how you will create. Here you can see I have 3 dimension tables, I have 1 fact table, right? So there are 3 dimension tables, 1 fact table, and similarly you can have multiple number of dimension tables, or you can have multiple fact tables as well, right? So this is it about the data modeling in this particular aspect. If you click here in the properties, you can see the relationship for this table. In table fact sales, you are seeing the column date, cardinality is many to one, with table dim date on the column date, right? If you want to create this relationship as inactive, you can select here and relationship will be inactive. right? If I click apply changes, you will see it will be dotted line now, right? You can see this is my dotted line. Previously it was solid line. Dotted means the relationship is not there, it is inactive, right? So this won't filter out the data. All right, so now I would say, going back to my presentation, I would like to explain the different types of schema that are used in Power BI. All right, so you can see here in data warehouse schema, I have star schema, I have snowflake schema, I have galaxy schema. There are three types of schemas. Let me just explain you what is data warehouse. So data warehouse schema refers to the way data is organized and structured in data warehouse. So we have a data warehouse, how the data is organized, how the data is structured, it is the schema of that particular system. A data warehouse is a large centralized repository of the data, right? It can be said as the repository where all the data is stored, right? It is designed for querying and analyzing, and it is typically containing the data from multiple sources. So you have multiple sources through which the data is coming and transformed and finally used for your analysis, right? The schema of the data warehouse defines the relationship between these tables, the structure, and any constraint or rules. So overall, you can say the schema will define everything. So schema defines relationships, it defines structure, it defines constraints or any rule that governs the data, right? So this is really important for organizing and structuring your data and making it easy to analyze and visualize. So finally, in Power BI, you can connect to data warehouse and import data into your reports and dashboards. When you do this, you can select the schema you want to use and specify the tables and columns you want to import, and also create the relationships between these tables as needed to support your analysis and reporting, right? So I hope you understand the meaning of data warehouse schema. And there are three types of schemas: star, snowflake, and galaxy, which are predominantly used. Otherwise there are various other schemas, right? So this is very important for everyone, right? So what is the difference between star schema, snowflake schema, galaxy schema? What is it and which schema to use when, right? So first of all, I would like to start with star schema. Star schema involves a central fact table surrounded by several dimension tables. As you can see here in this particular table, right? So this is my fact table, right? One fact table, as I explained previously. I have this as dimension table, dimension table, dimension table, dimension table, and dimension table. So there are total 5 dimension tables, and this is depicting as a star. You can see this is being shown as a star. So this is why it is called star schema, right? So there is one central fact table, and then there are various nodes which are called as dimension tables, right? So you can have the product master, you can have date master, you can have reseller master, employee masters, and then territory or geography masters. So you have various masters which we are calling it dimension tables, and there is one fact table which is transaction table. All the data is updating each and every day, right? So this is my star schema. So dimension tables in the star schema contain descriptive information about the data in the fact table, such as customer demographics or product categories. Each dimension table typically has a primary key. So each dimension table should have a primary key, because of which it will connect with the fact table, right? It can be created using Power Query Editor or by importing the data from database. All right, so this is about the star schema. Now let's understand the snowflake schema. The snowflake schema is a type of data modeling technique that is similar to star schema, but it involves the normalizing the dimension tables into multiple related tables. So what it is saying is, so I have one fact table similar to star schema. I have, let's say, 5 dimension table, but I will also have another dimension table that will connect with the dimension table already there in the system. So there would be one dimension table which is connected with another dimension table which is now connected with the fact table. So there would be indirect relationship, right? So this is how the snowflake also looks like. This is why the name of snowflake, right? By normalizing the dimension tables, the snowflake schema reduces redundancy and improves the data consistency, right? So if you say you have 4 dimension tables and these are directly connected with the fact table, then that is star schema. But if I say there is one dimension table which is connected to another dimension table and that dimension table is connected to fact table, then it is called as snowflake schema, right? Now coming to galaxy schema, which is not that famous. Galaxy schema can consist of multiple fact tables, so it can have multiple fact tables. As we discussed in star schema and snowflake, there is only one fact table, right? So you can see only one fact table is there, but in galaxy schema there will be multiple fact tables, right? This is also called as fact constellation schema, right? So because we have multiple fact tables and there would be multiple dimension tables, the structure looks like a galaxy, or you can say there are 2 stars, that is why it is called galaxy, right? Because the collection of stars is called as galaxy. Okay, so I have written this. It is viewed as the collection of stars and hence the name galaxy. The dimensions in this schema are separated into segregated dimensions which are having different level of hierarchy, right? For example, geography, region, country, state and city has 4 dimensions, right? So if I have a geography master, in geography master I have region, like region as, let's say, North America, South America, Asia, Europe, and then countries, states and cities, right? And then further each column can have another master table, right? So it is like that. Alright, so in this video I explained you what is data modeling, right? It is very important. If you're working on Power BI projects, you need to understand what is data modeling and the basic concepts, right? So I have explained that. Then what are the good features, or you can say what are the features for a good data model, right? If you want to create a perfect model or good data model, what are the important features to understand, right? Then I explained you what is the difference between fact table and dimension tables. These are really important concepts. Then I explained what is primary key, what is foreign key. These are very important terms to understand if you are also working on SQL. These are the things which will give you a huge progress, right? Then I explained you data warehouse schemas, what are the schemas and how to use them. The most important is star schema, then there is snowflake schema, and then you can work on galaxy schema as well, but star schema and snowflake schema are the most important schemas, right? So overall I explained you each and everything in detail. In my next video I will explain you end to end practically how to implement a perfect data model in Microsoft Power BI. Till then, I would really request you to watch my other videos. If you are interested in data analyst journey, I have created some videos on Power BI, SQL, Excel, and then I will be creating some videos on Python as well in the future. Then do subscribe, share across with your friends, and then please comment below if you have any query, if you want to understand any particular topic, if you want me to cover that particular topic, if you want to give any particular feedback, you can comment below or you can mail me. Do let me know, and please shower your support so that I can create these kind of videos in the near future as well. Till the next video, bye bye. Thanks a lot for watching.